tutup kamera, dengar. So chapter 5 baru masuk wireless local area network kan. So benda ni kalau kata ITT575 chapter 2 dah start dah. Kan chapter 2 atau chapter 3 macam tu dia memang start dengan LAN dengan WAN. Chapter kedua dah start dah dengan LAN. Yalah basic wireless kan. Kita ambil terus ke LAN lah sebab kita pakai Wi-Fi, kita pakai apa nama hotspot kan. So consider as LAN lah. Ke hotspot pen. Boleh jadi pen kan. Okey. Kalau orang putih panggil LAN, Melayu panggil LAN lah. Macam tu juga kalau kata manual panggil abaman. Kan dalam Linux, Unix kamu tu kita panggil abaman. Kalau orang putih abaman pelik kan. Kan. 5.1 Overview of Wireless LAN. 5.2 Overview of IEEE 2.11 Standards. Macam pen sebelum ni kan. And then 15 dia ni 11. Topologies on IEEE 2.11, Topologies 5.3, 5.4, IEEE 2.11 medium access mechanism. Alright, and last is 5.5. We go through to MANET or mobile ad hoc networks. Yang ini MANET dia main dengan hotspot juga ni kan. Right. So yang kata hotspot dia boleh pergi pen, dia boleh pergi LAN kan. After complete this chapter, upon completion of this chapter, a student should be able to explain the differences or similarities of SSID, BSSID and ESSID and their functions. So student should be able to compare lah kan. Kalau compare, kalau dalam final exam dia tanya soalan give 3 comparison. Maksud bila comparison sama ada different ataupun similarities kan. Dia boleh dua-dua. Kalau comparison boleh compare yang sama dan juga boleh bagi jawapan yang sama dan juga yang berbeza. Kalau ditanya differentiate, dah tentu apa nama, kalau differentiate baru cerita yang beza saja kan, yang different saja. Kalau tapi tak pernah ditanya yang what is a similarity kan, give 3 similarities, tak ada lagi kan. Tapi selalu dia akan tanya compare lah kan, similarity selalu dia tanya compare. So apa beza kamu dengan nyamuk? Siapa tahu?
Tahu saya.
Dua-dua mengganggu tidur malam saya kan. Nyamuk kan. Pinjam apa nama jet punya pick up line kan. And then after this chapter, student should be able to comprehend IEEE 2.11 standards and topologies. Students should be able to explain IEEE 2.11 medium access control, and last, students should be able basic operation and key components of MANET. First, we look on the overview of wireless LAN. A wireless local area network, WLAN, is a group of collocated computers or other devices that form a network based on radio transmissions rather than wired connection. So a Wi-Fi network is a type of WLAN and is based on the IEEE 2.11 standards. Data is sent in packets. The packet contain layer with label and instruction that, along with the unique MAC media access control address assigned to endpoint, enable routing to intended location. Ini cara macam mana dia boleh perform a wireless LAN. By wireless, radio transmission, tak guna wired. And then data is sent in packet. The packet contain layer with label and instruction that, along with unique MAC, and then assigned to endpoint, enable routing to intended location. Kan? Sebab tu dekat wireless tu dah ada router. Nampak tak? Dekat wired kalau kita nak connect sama-sama tak perlu router kan. Kita pakai switch tak apa dah kan. Nampak? Dia beza kan? Okay. Paket dalam wireless ni dia lebih kepada macam nak cari tuju dia guna routing kan. The last link with the users is wireless to give a network connection to all users in a building or campus. So, tapi untuk wired kita tetap pakai juga untuk wireless ni sebagai backbone. Okay, so kat sini tulis the backbone network usually use cables. So wired lah. Okay, ni contoh lain. Okay, connect laptop ni connect kepada access point yang berbeza. And then daripada access point ni akan ada backbone dia wired guna switch. Nampak tak? And then boleh pergi connect through WAN. Okay, wireless area network. Wide area network. Okay, WLAN used to have high prices, low data rates, occupational safety concern, and licensing requirements. Problems have been addressed. Popularity of WLANs has grown rapidly. So network with hundreds of feet coverage. Siapa nak masuk? Admit je. Tapi kamu boleh admit kan? Popularity of WLAN has grown rapidly. Network with hundreds of feet of coverage. Okay, boleh pergi 100 feet lah. Betul ke? Suitable for building and campuses. Macam mana beri satu kaki lah? Oh, satu kaki, bukan 1 meter. Provides end user access to wired LANs. Wireless LAN provide balance of performance, cost, availability, technology evolution. Kan, ada jimat sikit lah cost kan. And then performance pun okay, availability dan okay, technology evolution. So LAN punya benefit, extended reach, wireless LAN enable computing to happen anywhere, even when carrying high data loads and advanced web application. So device flexibility, a wireless LAN support use of wide range of devices such as computers, phone, tablet, gaming system and IoT devices. So ada an easier installation and management, tak perlu nak sabut-sabut dengan wired kan. A wireless LAN require less physical equipment than a wired network, which save money, reduce installation time and takes up less of a footprint in office setting. And juga scalability, wireless LAN is easy to scale. Adding user is as simple as assigning a login credential. Senang je kan, tambah saja apa nama wireless router baru, apa nama kita boleh scalable, nak banyak mana pun boleh kan. Tak cukup tambah kan, tak payah nak letak satu-satu point type macam wired kan. And then network management, nearly all management of wireless LAN can be handled virtually. A single software interface can provide visibility, manage users, monitor network health and collect data. Network management senang lah kan. Kadang-kadang kita nak buat shaping kan, nak bagi nak allocate bandwidth 50% kat siapa, 30% kat siapa. Ni senang, pakai wireless senang. Network management. So in many respects, the IEEE.11b wireless LAN standard is similar to that the classic IEEE.3 Ethernet LANs. Okay, so similar. 70 LAN with limited geographic coverage, multiple station with 48-bit MAC address, shared transmission medium, use broadcast technology, CSMA-based medium access control protocol, and last similarity is comparable data rates 11 megabit per second ataupun 10 megabit per second. Masa dulu kan wireless 802.3 kan dia 10 100 kan, sebelum ke giga kan, lebih kurang sama kan. So wireless sekarang mungkin dah boleh pergi ke giga kan, tapi wired sekarang dah ada 10 giga kan, 10 giga tapi kamu kena ada network card dia juga kan, susah juga. Differences pula, okay. So wireless adalah air interface versus wired, sama ada coax ataupun twisted pair kan. Apa lagi, fiber, okay. Wireless propagation environment, so dia ada multipass, higher error rate. Higher error rate ni selalu lah kan, due to interference, selalu ada banyak gangguan lah. Successful frame ACK by receiver, okay. So kena ada ACK, okay. Mobile ACK ni apa? Lupa dah.
Apa message acknowledge message.
Dia sebenarnya flag je dalam paket kamu tu ada ACK. Maksudnya dia ada bit untuk ACK. Maksudnya kalau ada satu maksud dia ACK lah. Kan? Dalam header tu kena baca balik TCP header untuk ni kan. And then mobile station versus fixed station. So betul lah dia untuk apa nama acknowledge kan. Okay, mobile station versus fixed station, half duplex versus full duplex operation, hidden node and exposed node problems, CSMACA versus CSMACD, multiple data transmission rate 1 to 5.5 and 11. Okay, ni data rate ada banyak kan. Sekarang ni berapa? 54 lagi. 600 kan? Kena 100. Combine lah. And then infrastructure mode versus ad hoc mode. Access point send beacon frames. Apa tugas access point? Kita pakai access point. Apa beza access point dengan wireless router?
Access point dia gateway lah kan, daripada internet ke user punya network.
Access point ni sebenarnya dia adalah untuk nak terima signal wireless lah. Kan? Wireless router tu maksudnya dia buat routing lah sikit kan. Dia nak pergi ke wired kan. So maksudnya wireless router kena ada AP lah dalam dia. Kalau tak ada AP macam mana dia nak masuk kan. So because mobile choose AP based on signal strength. So mobile sendiri yang akan cari AP. Sekejap ada call. Alright. Sorry. Kat mana tadi kita?
Access point.
Okay. Access point send beacon, and then mobile yang akan choose access point. Alright, based on signal strength. So selalunya laptop ataupun handphone kamu, kita boleh pilih access point yang mana yang kita nak kan. So kan sekeliling kan ada banyak access point, so kita yang pilih lah. Alright, dia based on SSID kan, pasanan. Okay, so multiple channel access protocol supported, CSMA, CA, DCF, PCF, RTS, CTS. Okay, MAC layer can provide error control, retransmission, rate adaptation, and etc. And then kita guna direct sequence spread spectrum, the SSS, signal spread across 22 MHz channels. So kalau siapa pasang dalam test 1 baru ni, saya termasuk chapter 5 yang ini ada juga soalan masuk kan. Tapi saya tengok ada je, ramai je jawab betul. So far okey kan? Tak ada komplain kan? So puas hati tak dengan test kamu?
Okey je sir.
Okey kan? Kita termasuk kan? Saya dah tengok, alah, baru pasan kan? Right. And then multiple wireless access point. So sini ada satu, ni channel apa ni? 11 apa ni? Satu, 6, 11. Siapa tahu? 1 ni apa, 6 ni apa, 11 apa? So 1, 6, 11 tadi bukan speed lah kan? 1, 2 ni, bukan? Kita tunggu graf, ada graf kan? Tak ada. Okay, application of wireless LAN, LAN extension, safe installation of LAN cabling. Okay, is relocation and other modification to network structures. However, increasing reliance on twisted pair cabling for LANs. So most of the building already wired with Cat3 cable. Newer building are preview with Cat5. Masih ada lagi kan? Yang pakai Cat5, Cat3 ni lagi lama lah ni kan? Okay, wireless LAN to replace wired LAN has not happened. Inside environment rules for the wireless LAN, building with large open area, manufacturing plant, stock exchange, trading floor, warehouse, historical building, small office where wired LANs not economical, and may also have wired LAN, and then server and stationary workstation. So dia adalah sebagai extension kepada local network yang wired tu. And then second is sebagai cross building interconnect kan. Connect LAN in nearby building, point to point wireless link, connect bridge or routers, not a LAN per se. User include this application under heading of wireless LAN. Kan kadang-kadang kita nak tarik fiber kan, tak boleh kan, nak cross antar building, so kita boleh gunakan wireless LAN. Dulu saya pernah kita orang ada projek nak pasang kamera tau, nak pasang CCTV. CCTV kan ada tak sini? Ada tak? Ad hoc network tak ada. Okay, tak ada. So yang ni lah kah? So kita nak pasang CCTV dekat bukan jana kuasa ni. Dekat stesen sungai. JPS selalu dia ada sungai-sungai, dia ada stesen-stesen dia kan. Untuk dia nak monitor apa nama air kan. Selalu dalam sungai tu jauh dalam masuk, kalau kata estate tu kena masuk dalam estate kan. So kita nak pasang CCTV, tapi masalahnya macam mana nak monitor dia, mana ada nak tarik wired kan, susah kan. So kita boleh guna wireless LAN, kita tembak dia jadi macam dia sambung, dia panggil apa saya tak ingat, dia macam hub lah kan, dia boleh tembak jauh juga kan. Okay, nak pakai apa nama, nak pakai 4G ke 3G ke masa tu, line tak ada kan tu kan, susah juga kan. So kita guna solution wireless LAN lah. Nak pakai microwave mahal pula kan. Microwave tu dah jadi macam pakai GSM, letak satu pencawang tu kan. Okay, third application of WLAN is nomadic access, link between LAN hub and mobile data terminal. So seperti laptop or notepad computer. So it can enable employee returning from trip to transfer data from portable computer to server. So and also useful in a standard environment such as campus or cluster of building. So user move around with portable computers may wish access to server on wired LAN. And then yang kita nak pergi ke MANET ni kan, sebagai ad hoc network. So temporary peer-to-peer network, no AC set up to meet immediate need. So example, group of employee with laptop convene for a meeting, employee link computer in a permanent network for duration of meeting. Ni pentingnya kan, maksudnya jadi ad hoc je. Sekejap je kan. Maksudnya memang mobile lah kan, mobility lah. Kita nak pakai satu network kat sini je, lepas tu tak pakai dah kan. So element of wireless LAN, so kita ada AP, access point. Okay, the AP is a wireless LAN. Dia beritahu AP ni sini adalah wireless LAN. So transceiver or base station that can connect one or many wireless devices simultaneously to the internet. Okay, Wi-Fi card, so the card ni maksudnya adapter lah kan, Wi-Fi adapter. Kan kadang-kadang laptop lama tak ada Wi-Fi adapter kan, kena beli USB kan, cucuk kan, sama kan. Ataupun Wi-Fi kamu rosak dah ke, laptop kamu rosak, boleh kena beli dia punya USB adapter dia lah kan. Sebenarnya dia adalah network card lah. Sebab apa dia card, maksudnya dia network card lah kan. They accept the wireless signal and relay information, they can be internal and external. And then safeguards, kena perlu kan, ada safeguard, firewall and antivirus software protect network from uninvited user and keep information secure. Kan, kena ada protection sikit lah. So habis overview of wireless LAN, kita pergi ke overview IEEE 2.11 standard. So the original 2.11 standard was published in June 1997 as IEEE standard 2.11 1997, and it is often referred to as 2.11 prime because it was the first wireless LAN standard. Alright, so the standard was revised in 1999, reaffirmed in 2003, and published as IEEE standard 2.11 1999. Tahun ROR 2003. Okay, so on March 8 March 2007, another iteration of the standard was approved, IEEE standard 2.11 2007, and on March 39 2012, the IEEE standard 2.11 2012 standard was approved. So dalam exam ada kan, dalam online test saya ada buat 2.11 to 2012 kan.
Ada.
Maksudnya dia adalah 802.11 lah kan. Kalau kita belajar 802.11 tu sebenarnya kita pakai yang last approve ni, yang ni lah kan. Kan, standard yang kita approve sekarang adalah 802.11 2012 standard. So IEEE specifically define 802.11 technology at the physical layer and the MAC sub layer of the data link layer. Yang kita belajar sebelum ni kan, bagi dua. kat data link map dengan LSC kan. As defined by 802.11 prime yang mula-mula tu kan. Okay, the frequency space in which either FHSS or DSSS radio can transmit in license free, so 2.4 GHz industrial, scientific and medical ISM band. So DSSS 802.11 radio can transmit in channel subdivided from the entire 2.7 GHz to 2.4835 GHz ISM band. So the IEEE is more restrictive for HF-SS radio, which are permitted to transmit on 1 MHz subcarriers in the 2.402 GHz to 2.480 GHz range of the 2.4 GHz ISM band. So the majority of legacy WLAN deployment use frequency hopping, but some DSSS solution were available as well. So selain daripada 2.4 GHz, kita pakai apa untuk wireless LAN? 5 kan?
5 GHz lah.
5 GHz kan? Dia sebab kita sekarang dah GSM kita pun dah 5G. Kebetulan kita pun ada 5 GHz. Boleh keliru bab tu kan? So kalau 5G jangan tulis jangan tambah HZ, tapi kalau kita nak mention 5 GHz patut tulis 5 GHz lah, baru senang kan. So data rates are defined by the original 802.11 standard were 1 megabit per second and 2 megabit per second regardless of which spectrum technology was used. So yang ini, yang sebelum ni betul lah, 1 and 2, 2 and 3, 1 and 2, 5.5 dengan 11 kan. Original mula-mula. Okey, mana ni? Data rate is number of bit per second the physical layer carries during a single frame transmission, normally state as a number of million of bits per second. Okay, megabit per second. Keep in mind that data rate is the speed and not actual throughput. Data rate bukan throughput. So maksudnya kalau kata kita buat analysis, okay, kita buat analysis, kita boleh collect data rate dan juga throughput kan. Dua benda berbeza. Okay, bandwidth lain pula, bandwidth yang hertz tu kan, tu kita punya bandwidth. Okay, dia hertz macam dengan dia punya, memang ada 2.4 GHz kita pakai dekat mana kan. Maksudnya yang free license 2.4 GHz semua orang boleh pakai, and 5 GHz boleh pakai. Yang lain-lain frekuensi tu kan tidak dibenarkan kan, kena ada license kan. Alright. So 2.4 dengan 5 GHz ni diperuntukkan untuk Wi-Fi lah kan, wireless LAN. And then berapa banyak dia boleh pakai adalah bandwidth dia lah kan. Lalu bandwidth ni dia punya pipe dia lah kan. Okay, release 1999. Okay, kita ada B, and then kita ada G 2007. Sama kan, B dengan G kan, selalu sama. And then 2009 11N. Kat situ kita namakan dia Wi-Fi 4. Tapi sebenarnya tak ada orang sebut pun Wi-Fi 4 kan. Bila Wi-Fi 6 yang baru ni, AX ni baru orang sebut Wi-Fi 6 kan. Wi-Fi 5 pun selalu tak ada orang sebut kan, sebab dia AC kan. Okay, Wi-Fi 4 dah kita panggil N kan. A, B, G selalu kita kat sini lah Wi-Fi awal-awal. Dia ikut tahun dia dah lah. Okay, 2009. So kat situ kita dah ada N ni, kita dah ada 2.4 dengan 5 GHz. Kalau AC dia pakai 5 saja, nampak tak? Okay, and then Wi-Fi 6 pakai balik 2020. Okay, 2.4 and plus 5 GHz. And boleh pakai 6 ni kan. Wi-Fi 6. So dia punya besar sikit bandwidth dia 80 160 MHz. And then Wi-Fi 7 dia orang tengah try. Okay. Mungkin boleh release 2023. Oh dekat lah kan. Pakai sama macam Wi-Fi 6. And then dia punya bandwidth dia lagi besar lah. 240 dengan 320 MHz. Ini tujuan dia kenapa dia buat. Okay. Alright, so kat sini dia ada tulis this table ada yang tulis ada absolute, ada yang masih kita pakai. Okay, ia apa nama operating band, nampak tak? Ni yang lama yang ABG tu kita ganti dengan ACAX, nampak tak? Ada kan? So ada N. Okay. So Wi-Fi 6 2019 kan. Maksudnya dah release lama dah. And then kita ada yang kedua E-Extend kan. Okay. Tahun ni ada tambah satu lagi frekuensi 6 GHz. Okay. Semua dah pakai WPA3. And then modulation ada QM 1K QM. Okay. 1024 QM. And then MIMO 8x8 lah kan. Alright, so yang kita pakai ni boleh sekarang dah boleh pergi 9.6 gigabit per second. Dan nak pergi pada 10 gigabit kan. Wired pun dah 10 pun tak ramai yang pakai kan. Okay. Boleh pergi, maksudnya kena betul-betul mengadap dia lah kan. Expected Wi-Fi 7 boleh pergi 46 gigabit per second. Laju kan. Okay, next code BE lah. 2.11 BE. AX BE. Because of media access method and communication overhead, aggregate throughput is typically 1/2 or less of the available data rate speed when using a 2.11 ABG lah teknologi. The medium access method are more efficient with a 2.11N and a 2.11 AC, but there's still a 30% or 40% overhead due to medium contention overhead. So dia atas on media access method. Okay, kita tengok satu-satu. A2.11a developed in 1999 used 5 GHz and physical layer developed for maximum theoretical transmission rate 54 megabit per second. The standard use orthogonal frequency division multiplexing encoding scheme FHSS or DSSS. So pada tahun yang sama 1999 selain daripada A kita ada buat B yang standard pakai lama ni ABG ni, maksud B dengan G ni kita pakai lama because dia pakai 2.4 GHz kan. Dengan G pun sama 2.4 GHz. So bandwidth sama 20 ni 11 lah. Okay. So A2.11b use orthogonal frequency division multiplexing encoding scheme DSSS. Apa beza dengan G? Dia guna OFDM modulation, tapi dia compatible lah B dengan G. Okay. Kemudian 11N Wi-Fi 4. Okay, so sepatutnya ada nama dah Wi-Fi 4, tapi kita tak panggil, kita panggil wireless N lah, kita panggil wireless N. Okay, developed in 2004 but began to use in 2009. Dah lama rupanya, 2009 baru pakai. Okay, use multiple channel, bandwidth 20 and 40 over 40 and or 40 MHz and frequency 2.4 GHz and 5 MHz. Okay. Okay, masa ni dia pakai 64 QAM modulation. MIMO system for 4x4 kan, macam apa nama forming drive kan. And OFDM, the maximum theoretical transmission rate is about 100 megabit per second. Yang ni saya sebut tadi kan, 600 kan. Okay, so on 11N, so compatible with our previous standard ABG, most user devices still use this standard. Kalau kamu beli router yang murah yang RM100 lebih tu selalu yang inilah 11N Wi-Fi router. Kan? Okey. Saya rasa lah sebab saya ada beli juga kan. Saya tanya kenapa yang Asus ni mahal sampai 300, ada 500, ada yang 1000. Oh, rupanya sebab this teknologi kan ada pakai Wi-Fi 5, Wi-Fi 6 kan. Kalau yang 100 lebih tu inilah dia kan. RM100 lebih kan. Kadang tak tahu RM100 boleh dapat RM100. Tak sure lah, RM100 lebih boleh dapat kan. Bawah 200 lah kan. Bawah 200 boleh dapat yang ni. AC ni saya tak sure, mungkin dah kalau harga dah drop, mungkin dia boleh dah sama harga dengan yang ini kan. Because it developed in 2013 AC ataupun Wi-Fi 5. The frequency band is 5 GHz and channel bandwidth can be 20, 40, 80 and 100 MHz. So this standard use 256 QM modulation, MU MIMO antenna system 8x8 MIMO and OFDM. So the theoretical transmission speed up can be up to 7 gigabit per second. So Wi-Fi 5 is compatible with previous standard. So this one, the new standard, which enable high speed and serve a large number of user, airports, e-classroom, restaurant, etc. So maksudnya siapa yang dah pakai yang obsolete tadi, ABG tadi, so pakai ni tak ada masalah kan. So, maksudnya dia boleh tetap boleh connectkan network card yang Wi-Fi adapter yang ada hanya ABG kan, sebab dia boleh compatible. Yang ini kita tak ada tulis. Ada compatible tak? Ada juga. Wi-Fi 6 pun compatible with previous standard. So semua ada lah. Walaupun dia obsolete, tapi siapa pakai yang adapter lama still boleh connect dengan ABG, dengan N, dengan AC, dengan AX. So as Wi-Fi 6 was developed 2019, frequency band are 2.4 and 5 GHz and channel bandwidth can be 20, 40, 80 and 160 MHz. So this channel standard use 1011024 QM modulation, FDMA and MU MIMO 8x8 juga kan, macam AC kan. It offer the theoretical transmission speed up to 9.6 gigabit per second. So Wi-Fi 6 is compatible with previous standard. This is the data standard. It enable high transfer speed and service to a large number of user, restaurant, airport, cafe, e-classroom, etc. Sama je ni. Kan? Right. So, cuma kita boleh nampak lah penggunaan dia semakin lama semakin banyak kan, untuk IoT, untuk virtual reality kan. Okay. Ini apa, streaming ke? Uploading, downloading, apa lagi? Untuk synchronization, untuk nama apa? CCTV kan. Gaming, streaming. Ni streaming kan? Ni streaming. Right. Okay, 3 original physical layer specification. Infrared, ulang balik kan, infrared. Okay, FHSS and DSSS. Okay, infrared tangent use a light-based medium, auto and infrared medium was indeed defined in the original 2.11. The implementation is obsolete. Infrared device are known as Class 15 devices. Untuk FHSS, radio frequency signal can be defined as narrowband signal or as spread spectrum signal. So ulang balik, frequency hopping spread spectrum. So radio frequency signal is considered spread spectrum when the bandwidth is wider than what is required to carry the data. Frequency hopping spread spectrum FHSS is a spread spectrum technology that was first patented during World War II. FHSS ada sejarah dengan World War II. So DSSS, direct sequence spread spectrum, is another spread spectrum technology that use fixed channel. Okay, habis ni kita masuk satu lagi ya. Nanti kita sambung yang MBSS tu next week lah kan. Okay, so kita masuk satu lagi, ambil sub channel untuk ini. So kita tengok AO2.11 Topologies. So network topology ada physical ataupun logical layout of the network. So dia boleh jadi physical dan dia boleh jadi logical atas kertas kan. So that is topology. So specify the structure and the network. So maksudnya kamu kena ambil network design lah. Baru faham kan. Selalu dalam ni kita dah tegang dah daripada awal-awal ambil datacom. Kamu ambil datacom tak?
Ambil sir.
Kan? Belajar itu apa topologi kan. Logical topology describe the communication mechanism, how data flow within a network used by devices on the LAN for the transmission of data. So maksudnya kita buat plan lah, kita buat design atas kertas lah orang panggil kan. Walaupun sekarang tak atas komputer semua kan. Kan kita akan listkan semua host and then dia punya connection dekat mana, kalau ada backbone, router dekat mana, and then cloud dekat mana ataupun internet kan. Route to internet. And then kita boleh letak IP address dia setiap satu kan. Mungkin ada lebih daripada satu IP address. So that is a logical topology. So logical topology determines how the host access the medium to communicate across the network. Okay, for example, tokering access method, bus access method. So tokering ni kamu ingat tak topologi topologi ring token pula dah kan. Token tu nak buat main taken kan. So the purpose of IoT point 11 is to interconnect radio cards. Every wireless device has a radio card. All wireless device are labeled as station ataupun STA. Topology defined by IoT point 11 standard adalah BSS, ESS and IBSS. Kan ingatkan iblis kan? Iblis kan? IBSS. Iblis jenuh juga kan? Tengok jenuh kita auzubillah kan. Okay. Basic service set, standard service set, independent basic service set. Alright. So topology ni kita tengok basic service set. So diguna satu single IP with one or more client station. A group of wireless network devices that are working with the same AP. So AP interconnect. Distribution system, wired backbone network station that are member of BSS are associated. Created linear to connection station do not communicate with each other, unlike IBSS must go through AP. So tak boleh cakap dengan ni terus, dia kena pergi dekat AP. So kalau kita belajar Bluetooth tu kita ada apa? Connect dengan apa? Siapa ingat? P-Connect ataupun Pi-Connect dengan satu lagi?
P-Connect dengan Scatternet.
Scatternet. So kalau kata BSS ni P-Connect ke Scatternet? P-Connect je kan? So maksudnya kecil je kan? So nanti combine banyak-banyak dia dah jadi macam Scatternet kan. Okay, so yang saya sebut tadi SSID adalah Service Set Identifier. So this is SSID is a logical name used to identify an auto point 11 network, wireless network. So in layman term, an SSID is the name for a wireless Wi-Fi network. Unique character string used to identify AP service set. AP will broadcast SSID and end user will see SSID only. So the SSID is a configurable setting on all 802.11 radios, including access point and client station. The SSID can be made up as many as 32 characters and in this case sensitive. Kan, so sama ada kita boleh letak ni apa nama simbol boleh, simbol boleh juga kan, kan dia macam pakai ASCII je kan, boleh. Cuma nampak dah Y-Pi kan, ada dash kat sini kan. Right. And then kita ada basic service set identifier, BSSID is the 48-bit MAC address and of access point. If you have two BSS near each other and they are both advertising the same SSID, a client and station need to identify to one BSS from the other. That's why we need BDDID nama dia. Macam dekat UiTM Jasin kat kampus kita kan, dia keluar SSID, guest, student, staff kan. Lepas tu kita pergi dekat AP yang lain pun dia tulis benda yang sama kan. Nampak tak? SSID dia nampak macam sama kan? Right. So in order for client to roam seamless, the AP must advertise the same SSID. Nampak tak? AP must advertise the same SSID. The client station, however, still need a unique layer 2 identifier of each AP. The BSSID provide each BSS with a unique identifier, thus the name BSSID. Okay. So ini kalau kita tengok dekat network analyzer kita kan, nampak macam ni kan. Okay, kita boleh tengok MAC header dia, dia dah tulis BSSID kan, ada sini. So dia adalah unik ya. Unik. Next is BSA, Basic Service Area. The physical area of coverage provided by an AP in BSS is known the Basic Service Area. So apa itu BSA? BSA is a physical area of coverage provided by an AP in a BSS. Okay, so itu adalah BSA. So client station can move throughout the coverage area and maintain communication with the AP as long as the received signal between the radio remains above received signal strength indicator ataupun RSSI threshold. So the size of handshake of BSA depend on many variables, including AP transmit power, antenna gain, and physical surrounding. When drawing a BSA, it's common to draw a circle around the AP macam ni to illustrate the theoretical coverage area. In reality, the real coverage area will have a disproportionate shape due to the existing indoor or outdoor environment. Kalau dia tak nampak sangat kan, okay? Tapi kita lukis macam ni je lah. Habis BSS, kita pergi ESS, Extended Basic Service Set, is where one or more BSS connected through the distribution system ataupun DS, or also known as a layer 2 backbone network. Backbone kita panggil dia ESS. So generally multiple APs and client station united by a single distribution system medium or station are associated with only one AP at a time. So often set up with multiple overlapping coverage cell, 15 up to 25% overlap to support roaming. Right. So that is a ESS. Kita tengok ni backbone kita dalam LAN pakai wired kan. And then kita ada access point, wireless client dengan wireless LAN. So LAN backbone ni kalau kata wireless, kejap ada call lagi. Siapa pula ni? Okay, so backbone kita panggil sebagai ESS. Kat mana tadi? Sini kan? Dah habis kan? 1525 support roaming. Banyak sangat call ni kan? So the BSS in ESS we share the same SSID, network name. Ni macam kat Shah Alam kan, kat kita Jasin kan. Student Jasin, staff Jasin. Each AP in each BSS we have a unique BSS ID MAC address. AP can be positioned so that set I would like to facilitate roaming. Wireless device choose AP based on the signal strength station going to the from one BSS to another with deal with handoff roaming. Tu cara dia. Okay, so seamless roaming is uninterrupted as a client move from one BSA to another. Walaupun kita tukar BSA, so tapi kita punya internet tetap dapat macam biasa. Kan tak ada masalah lah kan, uninterrupt. Okay, nomadic roaming, a client station leave a message of the first AP, lose connectivity temporarily, and then pergi next ni dia akan automatic establish balik. So walaupun dia dah disconnect, tapi bila dia pergi ke next BSA kan, so dia masih lagi boleh connect tanpa kena pilih ni kan, macam biasalah. Alright. Senangnya nak check dia seamless dengan nomadic ni. Kita download kan. Tapi download pun ada yang dia boleh auto resume kan. Ada yang tak kan. Dia based on session juga kan. Ada tak yang bila kita tukar AP tapi SSID sama, dia kena download balik daripada mula. Ada kan? Kalau perasan lah.
Ada.
Kan. So, maksudnya dia nomadic roaming lah. Okay. Maksudnya kat sini kenapa nomadic roaming dia tak ada apa? Tak ada coverage kan? Nampak sini. Sini ada kan? Dia tengah nak hand off kan? And next, co-location. Ni panggil co-location lah. A final example of ASS deploy multiple access point with overlapping coverage area. This 2.11 ESS topology is called co-location, and the intended goal is increase client capacity as opposed to roaming. So co-location is one method of providing coverage for a high density of client devices in the same area. Ni tak ada masalah kan? Alright. Sebab dia tengok dia overlap dia besar gila kan. Kan. Kenapa boleh jadi macam ni? Selalunya yang nak cover tu sikit sangat lah sini kan. Kalau tak kat belah sini tak sampai kan. Okay, yang next kita pergi yang last adalah Independent Basic Service Set. Okay, radio card that makes up IBSS are only client station, so tak pakai AP. So can have multiple client station linked together like ad hoc and peer-to-peer network. Frame transmitted directly between station, or station must use same channel, must have same SSID. SSID must be chosen. First station that start network generate the SSID. All session is an IBSS must contain for the half duplex medium, and at any given time only one STA can be transmitting. Okay, tak ada yang disebut tadi, ada 3 je kan sampai IBSS. Ni yang keempat adalah combination kan ataupun mesh. Semua sekali kena ada kan mesh. So 2.11 to 2012 standard service set of 2.11 mesh topology. So when access point support mesh function, they may be deployed where wired network access not possible. The mesh function are used to provide wireless distribution of network traffic, and set of AP that provide mesh distribution form a mesh basic service set MBSS. So mesh basic service set or MBSS requires features that are not necessary in BSS, ESS, or IBSS. So because the purpose of MBSS is different from the other topologies, one or more mesh AP will typically be connected to the wired infrastructure. This mesh AP is known as mesh point porter ataupun MPP. Macam kita punya MPP lah. Sometimes called ada ni MPP kita ada. Tak ada ni. Lukman? Ada ni. Mesh point porter lah. Lukman is mesh point porter. Sometimes called a mesh route or gateway. So the other mesh AP that are not connected to the wired network will form wireless backhaul connection back to the mesh porter to reach the wired network. Mesh AP that are not connected to a wired infrastructure are known as mesh point or MPs. Client sessions that are associated to the mesh point have their traffic forwarded through the wireless backhaul as stated earlier. And MBSS makes use of a wireless distribution system medium for backhaul communication. So usually the MBSS use the 5 GHz radio for backhaul communication.